This is Higher NAB, Unit 1, Outcome 1, the straight line topic. Within the topic we cover 3 questions, and really it's only the basics that are being tested in the NAB here. Let's go to the first question and we'll see that a line passes through the points 5, 2 and -4, -1. Find the equation of the line. So I know that to find the equation of the line I must find the gradient between the two lines first of all. So let's look at the gradient first of all. And what I'll do there is I'll use y2 minus y1 all over x2 minus x1. And what I'll do is I'll call this my point number 1. So I'll call that coordinate there x1 and that one y1. This will be my point 2, so I'll call that x2 and that will be y2 there. All I'm going to do is substitute the values that I find that match up with the letters here into the equation for the gradient. Right then, so y2 is -1, subtracting 2, which is y1, x2, which is -4, and x1, which is 5. So I'm going to take away 5 from that. So on the numerator, I've got -3. On the bottom, I've got -9. So these two cancel out, and what I'm left with here is positive 1/3. Okay, the two negative signs there, they will divide out and give me a positive number. Okay, so now I've got the gradient. What I can then do is I can then use either of these points and the gradient to work out the equation of the line. So what I'm going to do is I'm going to substitute. I'm going to substitute the gradient that I've worked out, which is 1/3. And I'll also substitute one of the points. Let's just choose the first one. Doesn't matter which one I choose, I can choose any to work that out. I'm going to substitute it into the general straight line equation, which will be y minus b equals mx minus a. Okay, so I've got b and a here, and these are going to be the coordinates of the point I'm substituting in. The a value will be here as the 5, and the b value will be here as the 2. So let's just substitute them in. So I've got y minus b, which is 2, the gradient m, which is 1/3, and the x value here is x, and I'm going to substitute the a, which is equal to 5. Okay. From there, what I can do is I can process that a bit further. So if I've got 1/3 here, or 3 on the bottom, I'll multiply this side over here by 3. I'll multiply this side out by the 1 that's on the top, so that'll be x minus 5, and then what I'll do is I'll gather things together. So I've got 3y, I'm going to leave the x over at that side, and what I'll do is I'll take the -6 over to here, becomes a positive, so that'll be +1. And that should be the solution to that one there. Right, let's move on to question 2. And question 2 is, we've got a diagram normally. And from the diagram that we have here, we can see that there's a line that makes a 74-degree angle with the x-axis. Okay, and what we've got to do here is just find the gradient of that line there. A couple of notes that are given. The scales on the axes are equal. Okay, and find the gradient of the line, giving your answer correct to 3 significant figures. So don't forget that part there either. So what I'm going to use here is I'm just going to use one of the formulas that I've learned. And what it is the gradient is equal to tan theta, or tan x if that's what you use. I'm going to then substitute in the value of the angle, and the angle is 74 degrees. So I'll put in a 74 degrees in here. What I'll do is I'll then type that onto my calculator, and what I should come out with is 3.48741 and some digits beyond that. I've been asked to do it to 3 significant figures to write my answer to that, so I'm going to go for 3.4, and cutting the number there gives me a 9. Okay, so my gradient is equal to 3.49. Let's look at the third question. Right, the third question here, we've got a line L has the equation y is equal to 4x plus 12. Write down the gradient of the line parallel to L. So I know that my gradient for L is equal to whatever's sitting there, 4. because remember that's just in the form of y is equal to mx plus c, and I don't have to do any manipulation at all to that. So my gradient's 4. For a parallel gradient, they're the same. So the gradient of the L is equal to the gradient that I'm trying to find out, which is just going to be equal to 4. Okay, so I've just picked that straight from there. Perpendicular gradient. So a perpendicular gradient to a gradient of 4 will be equal to, so the gradient perpendicular to L will be equal to, so all I'm going to do is I'm going to consider that gradient there as being 4, and that's just the same as 4 over 1. Okay. What I'm going to do for a perpendicular gradient, I'm going to flip the fraction over, just flip in, change the sign. Flip the fraction over and change the sign, and that gives me minus a quarter. If you want to see how that really works out, that's all you would need to do for the work that you have here. But what we've got is the gradient of L times the gradient of the perpendicular line that we're trying to work out is going to be equal to minus 1. You usually see that as m1 times m2 equals minus 1. Okay? Right, so if I substitute the values in for the gradient of 4 times the gradient of the perpendicular line to minus 1, so I'll just divide the other side there by 4, and that gives me the same answer, minus a quarter. And that's basically how it works. Right then, let's see how we mark this here. Okay, so the first thing I'm going to get is a mark for the gradient up here. Okay, the gradient of being 1/3. Okay, so the gradient of 1/3 in question 1. And the next mark I'll get will be for the working here, for substituting the gradient and the point into the equation. And remember, I could have used that point there as well. As long as I get that correct, that's the mark I'm going to get. So that's my 2 marks for that question. Moving up to question 2. And the mark I'm going to get here is for making sure that I've stated the tan 74. Okay, that's important to make sure that the angle gets substituted in. And also the second mark here for getting the answer correct to 3 significant figures. And finally, when I look at question 3, all I'm looking for is the gradient of 4 and the perpendicular gradient of minus a quarter. And that's my marks. So if I look at the questions here, I'm interested in getting out of 6 marks. I need to get 6 marks correct. Okay, so it's out of 6 marks. 4 marks I need to have correct to be able to pass the NAB. So it's testing the basic skills for straight line. And good luck.